Hello dear students, good evening to each and everyone. We are studying signals and system. Okay, so we are studying signals and system in comprehensive manner. First of all tell me, audio and video both are clear to you people? Am I audible properly? Audio and video both are clear to you people? Okay, so shall we start guys? This is lecture number 16 and today's lecture is very much important. First of all, in this class I will teach you addition of signals, subtraction of signals, then multiplication of signals. Then I will start calculation of energy of signals for both discrete time signal as well as continuous time signal. Okay, so tell me, am I audible properly? Audio and video both are clear to you people? Tell me guys. Okay, so let us start guys. Today we will study calculation of energy of signals part 1. So that first of all we study how to add two signals and how to subtract two. Okay, so here signal addition and subtraction, first of all they are asking x1 plus x2 guys. Okay, what will the resultant signal if we add these two signals x1 plus x2? Okay, so time by time you have to add the amplitude guys. Okay, time by time parallelly you have to amplitude, and if there is a sudden change, remember this thing, if there is a sudden change in amplitude, then you have to consider both sudden change in amplitude, then consider both minimum amplitude and maximum amplitude at that sudden change. See here, see in this signal there is a sudden change at origin, so while calculation, during the calculation, consider this amplitude first, then this amplitude, both amplitude you have to consider. Similarly here this is the sudden change in amplitude, so while calculating at this point, consider this amplitude first, then this amplitude also guys. Similarly here also, here also, here also, and here also. Okay, so simply remember, wherever sudden change in amplitude is there, so at that point consider both the amplitudes in addition, first this one, then second this one. Here first this one, then second this one, and similarly for these two cases also. So let us start guys, let us start. So here let us start. So here I am drawing the resultant signal. Okay, so resultant signal after addition, get these two, and the resultant signal is, here they are writing y1 of t. So this is 0, is at 1, at 2, at 3, at 4 guys. Now mark all the amplitudes guys. Here amplitude, correct. At sudden change you have to consider both the amplitudes. Here this amplitude, okay, here, correct, like this, sudden change here like this. Now at t equal to 0 guys, see at t equal to 0, amplitude here 0, so 0 plus 0, here amplitude is 0 guys, correct. Now at t equal to 0 again guys, both the, I told you guys, both the amplitudes you have to consider, lower amplitude and higher amplitude also guys. So first 0 plus 0, 0, then this 2 plus 0 guys, so 2 plus 0, here it is 2 guys, something around here 2. At this 2 plus 1 guys, so 2 plus 1, here it is 3 guys, correct. Next this one, so this is 1 1 plus 1, it is nothing but 2 guys, correct? Then next 1 plus 1 guys, sorry, yes, at t equal to 3 you can see 1 plus 1, it is nothing but 2 at here guys, at this point. At this point this amplitude is 2, so 2 plus 1, 2 plus 1, it is nothing but 3 guys, correct? At t equal to 3 you have to consider this amplitude also as well as this amplitude also guys. So 2 plus 1, it is nothing but 3. Now at t equal to 4, first this one, so 2 plus 0 at t equal to 4, this is 2, this is 0, so 2 plus 0, it is 2 guys, correct? 2. And at t equal to 4, 0 plus 0, it is 0 guys, correct? And all the point you have to write in sequence, you have to connect in sequence guys, okay? So if you connect all these point guys, then first this one, then this, then this one, this one, this and this, so this will be your resultant signal guys, this will be your resultant signal. Is this clear? Write in the comment box guys, tell me in the comment box, is this clear? So at this sudden change you have to consider both the amplitudes, minimum amplitude as well as maximum amplitude, minimum and maximum both you have to consider, okay? So let us write it properly guys. Okay, so here it is 0 plus 0, first here 0 guys, 0 plus 0, 0, 0 plus 0, 0, then next is amplitude is 2 guys, at t equal to 1, 2 plus 1 we got 3, then we got again 2 guys, then at t equal to 3, 1 plus 1 we got 2, then next we got 3, then again at t equal to 4, 1 plus 1 plus 0, okay, like this. So connect all the points, connect all the points, is 0 of course, so this is your final answer guys. This is your final answer, correct? Signal addition, and this process is applicable for all the types of questions, whatever it is, whatever the difficulty level, you can use this, okay? Here this amplitude is 2 and this amplitude is 3, and same procedure for the signal subtraction also, and same procedure for the signal multiplication also guys, same procedure for the signal subtraction, addition and multiplication, same thing guys. Is this clear? Tell me in the comment box. Is this clear to you people? Yes or no? Yes, that also, yes, that also true guys, that also true. If you multiply constant value with any shape, then the resultant signal will be same shape, but there is a change in amplitude, change in amplitude, okay? But simple, this method you can use guys, method you can use, time by time you can multiply the amplitudes, correct? Respective amplitude you can multiply, but just remember at sudden change you have to consider both the amplitude, meaning starting point and ending point both. See, this is the starting point here, this is the ending point, this is the starting point, this is the ending point, this is the starting point, this is the ending, this is starting, this is ending. So both amplitude you have to consider, whether it is subtraction, addition or multiplication. So this is the resultant signal guys, y1 of t. In the same way we can do the signal subtraction also, in the same way you can try this signal subtraction also. So see here, now signal subtraction, same way we can try, we can perform the signal subtraction also. So here this is 0, this 1, 2, 3 and 4. So subtraction, x1 minus x2, you can do x2 minus x1 also, resultant signal. Okay, and the resultant signal is y2 of t. Okay, now here amplitude guys, this amplitude, then this, okay. Here this amplitude, okay. Now again same thing guys, same thing, but now subtraction. So this is 0, 0 minus 0, here 0 guys, then this 2 minus 0, it is 2 guys, then here 2 minus 1, it is equal to 1 guys, then next 1 minus 0 is equal to 1 guys, then here is 1 minus 1, that is 0 guys, correct. 1 minus 1, sorry, yes, 1 minus 1 0, then next 2 minus 1 is 1 guys, next 2 minus 0 guys, that equal for 2 minus 0, it is 2 guys, next 0 minus 0, it is 0 guys. Okay, so the resultant signal will be like this. Correct, wait, let me check once. Correct. The resultant signal will be like this guys, you can see here, see 0 minus 0 0, 2 minus 0 2 guys, then 2 minus 1 1, then 1 minus 1, that is 0, then next here 1 minus 1 0 guys, then 2 minus 1 1, then 2 minus 0 2, and 0 minus 0, that is 0 guys, correct. Is this clear to each and everyone? Done. So here let me draw properly. Okay, so here again see 0 minus 0, this is 0 guys, 0, okay, 0, and 2 minus 0, that is 2 guys, then 2 minus 1 is equal to here 1, then 1 minus 1 0, then 1 minus 1 0, then 2 minus 1 1, 2 minus 0 is equal to 2 guys, 2, then 0 minus 0, but 0 here. So connect all the points in sequence guys, sequence in which plot you plot. Okay, this one, next see, this is simple subtraction, same as addition guys, same as addition, same procedure as addition, correct. There is no change in procedure, and same thing for the signal multiplication also guys. Same procedure you can use for the signal multiplication also. This is what simple signal subtraction, simple signal subtraction. Any doubt in this? Tell me, is this clear? Is this clear to each and everyone? Is this clear to each and every student? Tell me, each and everyone, yes or no? Done. Okay, if you have any doubt then please ask. In the same way we can do the signal multiplication also guys, signal multiplication also. Okay, so this is x1, this is x2, so we have to multiply x1 and x2 time by time. You have to multiply all the amplitudes. Now signal multiplication. Similar way, you can do this signal multiplication also. Okay, this is 0. Then next is 1, 2, 3. Okay. Again, mark all the amplitudes here. First this one, then this. Right here, this one, sudden change. Sudden change. So sudden change. Okay. Now at origin, guys, minimum with minimum and maximum with maximum. So starting point. This is the starting point. 0 into 0. It is 0, guys. Next, maximum point, guys. Ending point. So 2 into 1, guys. 0 into 0, 0. 2 into 1, nothing but 2, guys. Correct? 2. Next, this 2, guys. So 2 into 1. 2 into 1, it is 2. Next, 1 into 1, it is 1. 1 into 1, 1. Next, here, this is 1 to 2, guys. 1 into 2, it is nothing but 2, guys. Then here, 0 into 2 is 0. And next, 0 into 0, it is nothing but 0, guys. Then connect all the points, guys. Connect all the points, the sequence, correct sequence, guys. Then from here to what, guys? This one, correct, you can see. Then this point, then this point, then this will be your final answer. This is your final answer. Clear? So this is what signal multiplication, same as signal addition and subtraction, guys. Okay. Here you can see 0 into 0 is 0. 2 into 1, it is 2. Next, 2 into 1 is 2. 1 into 1 is 1. Then 1 into 2, correct, here 1 into 2, nothing but 2, guys. Then 0 into 2, 0. Then 0 into 0, 0, guys. Here. Okay. Point. Sorry. See, in the sequence, guys, you have to write in sequence from here to here, this point, then here, this point, then this point. Finally, last one is correct. So this is what signal multiplication, nothing but signal multiplication. Here. I hope all the students are getting signal multiplication. Is this clear to each and everyone? Signal addition, signal multiplication, and signal subtraction. I hope all the students are getting what I am saying. Clear to each and every student? I hope this is clear to each and every student. Fine? Okay, very good. Now, let us continue further, guys. Let us continue further. Suppose I am asking to draw, let me take one question, guys, practice question. So, x of t, sketch, I am asking to sketch x of t is equal to 2 pi t by 4 into 3 del t by 3. Pi means rectangular function, correct? See, pi means rectangular function with amplitude 2 and width 4, and del means what? Triangle function. Triangle function starting from -3 to +3, correct? -3 to +3 with amplitude, peak amplitude 3 guys. Okay. So would you like to solve this question? First of all, you have to draw this rectangle function, and below that you have to draw this triangle function. Then you can do the signal multiplication. Catch this one guys. Catch this one. Then we will start the next topic that is very much important, calculation of energy of the given signal. Energy of the given signal. So try this question. Try this question. And tell me the correct answer. Done, Nikhil? Done? So first of all, this signal is nothing but rectangular function from -2 to +2, width 4, amplitude 2 guys. And this is the triangular function from -3 to +3 with amplitude 3 guys. Rectangle function, then here triangular function, then here we will draw the resultant signal. Okay. So first rectangular function from -2 +2, -2 +2. Correct. Total width is 4 guys. So it is -2 to +2 with amplitude what? So this is the rectangle function 2 pi p by 4, and here triangular function guys. Triangular function 3 means -3 to +3. So this is 2 guys. This is -2, -2, something around here 3 and -3. So this is -3 +3. So -3 to +3 guys. -3 +3. With peak amplitude is 3 guys. Peak amplitude is here. Peak amplitude is amplitude. Correct. Here I am writing -3 +3. Now signal multiplication at -3. Correct. At -2, sudden change. Okay. Then here these are 2 guys. Sorry, at origin is at point here. Okay, now signal multiplication guys. So here this is -3 at -2, at 2 guys, 2, and this is at 3. Clear? 2 and 3 guys. 3. So at t equal to 3 guys, 0 into 0, this is nothing but 0 guys. Now at t equal to -2 guys, so this is what? 0 guys. First this point, first lower point, starting point, 0 into this, 0 into this, it is nothing but 0. Then 2 into this point guys. So you have to find the amplitude at this point. Let us consider this point is P guys. Correct? This point is P. So you have to find amplitude guys. So what is the value of slope? What is the value of slope? And I told you how to find this amplitude guys. Slope is what? Dy by dx. So So you can see dy is 3, dx is 3, slope is 1. Okay, so here dy by dx guys, this is dy, this is dx. You can see this is dy guys. So dy slope is 1, dy we have to find, correct, and dx is 1 guys. So dy is equal to 1. This is dx, this is dy. If slope is 1, dx is 1, then dy also 1 guys. Dy 1, this is origin. So this p equal to what? P equal to 1 guys. Yes or no? Here amplitude is 1. Yes or no? Correct? Here amplitude is 1 guys. So here 2 into 1, it is nothing but what? 2 into 1, it is 2 guys. 2 into 1, 2. Next at this point. So 2 into 3, this is nothing but 6 guys. Correct? 6. This amplitude is 2. Again, this is 2 into 1. Again, this is also 1 guys. So 2 into 1, it is 2 guys. And here at this point guys, 0 into 1 guys, it is nothing but 0. Then here 0 into 3, it is nothing but 0 guys. Correct? So you will get like this here, then this point, then this, here this point, finally this one. This clear? So this is your answer, and here amplitude is 2 and here this is 6. So here multiplication, this is your x of t, the resultant signal. Is this clear? Tell me, Nikhil, is this clear to you? Is this clear to each and everyone? So this is what guys, signal multiplication. This is what signal multiplication we studied. Correct? In this way you can do the signal multiplication. Done? Yes or no? Tell me in the comment box. Okay, very good. Very good guys. I hope all of you are getting what I am saying. So this is all about signal addition, signal subtraction and signal multiplication. Next topic is calculation of energy of the signal, which is very much important. We can say hot topic of first chapter. Calculation of energy guys. Okay, calculation of energy. So before starting this, the topic name, complete topic name is calculation of energy, power and RMS value of a signal. Okay. So how to calculate power? You might have studied in the network theory the power dissipation or power absorbed by any element guys, any element. Let us consider resistor guys, resistor. Let us consider resistor having resistance R ohm, having resistance R ohm. Let us assume the variable voltage across the resistor is V of t. We can say V of t is a voltage signal guys, correct, which indicates where voltage across the any element varying with respect to time. Okay, and due to this voltage, current also flowing guys from higher potential to lower potential. Let us consider current flowing through this, variable current flowing through resistor is I of t. It can be inductor also, it can be a capacitor also, it can be any diode, transistor. Let us consider any general element. So here the average power dissipated, the power dissipated, this resistor PR, it is nothing but V of t into I of t, correct, instantaneous power, or we can say V of t equal to I into R guys, I into R. So it is nothing but I square t into R, or we can say I of t equal to V by R. So V square of t divided by R. Okay, and unit is watt. Okay, if this is the voltage signal, this is the current signal, then unit is watt. Okay, now if this is this is what instantaneous power. If I am considering R equal to 1 ohm, then the dissipated power is known as what? Normalized power. Yes or no? It is known as what? Normalized power. Normalized power guys, correct, and which is given by simply square of the signal. Okay, square of the signal, it can be voltage signal or you can consider current signal. This is the normalized power. Yes or no? In short, what exactly I am going to say guys, in power formula and in energy formula, square of the signal will come, square of the signal. We will consider the general signal x of t and we will find the energy and power for the x of t. So in formula, square of the signal will come in energy formula as well as power formula. What is the energy, guys? Energy is nothing but what? What is energy, or what is the relation between power and energy? So power is nothing but what? Energy per unit time, guys. Power is nothing but what? Energy per unit time. Energy per unit time is nothing but power. So if in power formula square of the signal will come, then in energy formula also, guys, in energy formula also square of the signal will come, guys. Correct? Fine. Okay. So now Nikhil Mishra, this is the best method. You are talking about the previous question, but this is the best method. Okay, this is the best method to solve this question. Okay, and always you will get the correct answer. Always you will get the correct answer. So always follow this method. Okay, always follow this method, the easiest method. So now let us consider general signal x of t, guys. Any general signal x of t, and for that we want to calculate the power, energy and RMS value. Okay. So first I will teach you for the continuous time signal, then later we will see for the discrete time also. So here let us consider first a continuous time signal. If x of t is any continuous time signal, CT means continuous time signal, correct? Continuous time signal, then it's a total energy. Total energy means what? We have to integrate, guys. Integrate that signal from minus infinity to plus infinity. Okay, suppose if you want to find the area over a fundamental time period, then integrate the signal over a fundamental time period. If you want to find total area, then you have to integrate the particular signal from minus infinity to plus infinity, which gives the total area. In the similar way, if you want to calculate the total energy of the given signal, then you have to integrate. You have to integrate that particular signal from minus infinity to plus infinity. But we will take square. Why square? I told you, guys. I told you we will not simply take v of t, I of t. We will integrate the square of the signal, guys. Correct? For the total energy. So if the signal is x of t, then the total energy of the given signal is given by total energy of the given signal is total energy, guys. The formula total energy notation is E, signal x of t. It is nothing but, as I told you, guys, for total you have to integrate the given signal from minus infinity to plus infinity. We will take the square, but here I am considering the modulus also, guys. First you have to find the magnitude of the given signal and then square, guys. Now doubt is, sir, already we are considering square, then why we are taking modulus also, mod also, guys? Correct? We are taking square also and mod also. What is the meaning of mod? So if x of t is a complex value signal, if it is a complex value signal, then first of all you have to find the magnitude of that complex value signal, and then you have to follow the procedure. Okay. So here I wrote because x of t can be a complex value signal, guys. Okay. So here x of t is a complex value signal. X of t, it can be a complex value signal. Okay, complex value can be a complex value signal. Complex value signal means x of t is equal to a of t plus j b of t, guys. So real part is a function of t as well as imaginary part is a function of t. It is known as a complex value signal. Say for example, complex sinusoidal, that is e power j omega t, guys. So it is nothing but cos omega t Euler's form plus j sin omega t. So whenever complex value signal come, guys, then you have to take first modulus, that is mod. Okay, mod, and then you have to follow the procedure, then you have to use the formula. And how to calculate the magnitude, guys? So magnitude is nothing but square root of real part square plus imaginary part square. The formula to calculate magnitude of complex value signal. But suppose if x of t is a real value signal, only real, for pure imaginary and for pure imaginary value signal and for the complex value signal, you have to consider magnitude. But if x of t is real value signal, real value, pure real value signal. Suppose x of t is a real value signal. And what is the magnitude of the real value signal? Same. Okay. Then like x of t is equal to a of t. Then magnitude of x of t is magnitude of a of t. Correct? Magnitude of a of t, that is equal to what? A of t only. Correct? Magnitude is nothing but a of t. Okay. So the formula for the real value signal is the energy of real value signal is given by simply integration minus infinity to plus infinite x square of t dt. Guys, this is the formula. This is the formula if it is a continuous time signal. If it is the continuous time signal. That we will see in the Fourier series. How to calculate the ratio of seventh energy harmonic. Energy, not to energy, power, because Fourier series is for the periodic signal and all the periodic signal are the power signal. So the question should be the ratio of power of seventh harmonic to the sixth harmonic or sixth harmonic to the seventh harmonic, not energy, power, because Fourier series is defined only for the periodic signal and all the periodic signals are power signal. So that's why the question should be the ratio of power of seventh harmonic to the sixth harmonic to the seventh harmonic. That we will see in the Fourier series. Don't bother about it. Okay, it is very much easy, very much easy. Each and every topic I will teach you in the detailed manner, guys. You are getting premium content. You are getting the premium content on this channel, lecture in this series. Okay. So this is the formula to calculate energy of any signal, guys. If it is a complex value signal or pure imaginary value signal, then you have to take modulus, guys. And if it is a real value signal, then need not require to take modulus, not required to take mod. Okay. This is for the continuous time. Suppose x of a signal is a discrete time, then what will be the change in the formula, guys? Suppose this is a discrete time signal, then tell me, discrete time signal, then what is the change in formula? Its energy, total energy is given by change in the formula. Tell me, what is the change in formula? So instead of integration, now summation will come into picture. Summation. The integration from minus infinite to plus infinite. There is summation from n equal to minus infinite to plus infinite. Here mod x of t square, and here it is mod x of n square, guys. Simply you have to take magnitude of the sample, then square, then simply summation. So you have to do the square of each and every samples, then finally summation. That's it. For the discrete time, it is very much easy. Again, we are considering modulus because it can be a complex value signal. Here x of n can be a complex value signal. Correct? If it is a complex value signal, complex value signal. Correct? It can be a complex value signal. And if it is a real value, if x of n is real value signal, real value signal, then formula calculate energy of the given signal is summation. Did not require to take modulus, guys. Simply square of the samples and then summation, square of the amplitude of the samples and then add all that samples. Correct? This is for the discrete time. Okay, so these are the formulas to calculate energy of continuous time signals and discrete time signals. So first of all, we'll solve questions for the continuous time, then same thing we will see for the discrete time also. So let us start with first infinite duration signal. First we will calculate energy for the infinite duration signal, then we will calculate energy for the finite duration, finite amplitude signal also. So let us consider first question. Suppose you have to find, I am going to ask you to find the energy of x of t equal to e power minus AT into U of t. Now this is the right sided signal, so it can be increasing or it can be decreasing right sided depending on the value of A. Depending on the value of A, it can be increasing right side, it can be decreasing right side. Okay. Now energy will be finite or infinite, completely depends on the value of A, guys. Completely depends on the value of A. Okay. So let us start, guys. Let us use the formula. So this is the pure real value signal. So energy of this signal x of t is given by integration minus infinite to plus infinite x square of t dt. This is the formula, correct? So here energy is given by integration minus infinite plus infinite square. So it will be e power minus 2at is square of t dt. What is the square of the step function? So here square of the unit step function is nothing but u of t only. So energy is given by integration minus infinite plus infinite e to the power minus 2at into u of t into dt. Now see, u of t, this is 1 for t greater than 0, it is 0 for t less than 0. So for t less than 0, the integration, the value of the integration will be 0. For t less than 0, the value of this integral will be 0, guys. Okay. So if you replace u of t with 1, we replace the e to the power minus 2at. If you replace u of t with 1, then the change in the limit is from 0 to infinite, guys. Clear? U of t equal to 1, then the limit will be 0 to infinite, because for minus infinite to 0, u of t 0, answer of the integration will be here. Fine. So here the energy, now integration. So e to the power minus 2a t divided by minus 2a, it is 0 to infinite. If we put 0, then 1 minus e to the power minus 2a here infinite divided by 2a. Now the answer can be infinite or it can be less than infinite. Completely depends on the value of a. See, this power can be plus infinite, it can be minus infinite, completely depends on the value of a. Suppose if a is positive, if a is positive, see, if a is positive, then the energy will be finite or infinite. Tell me in comment box. For the positive value of a, it will be increasing function or decreasing function. Tell me in the comment box. So you can see here a positive, guys. Here a is positive. So if a positive, then this power will be what? Minus infinite. This is positive. Okay. Then the power will be the power minus infinite divided by 2a. Now e power minus infinite is 0. Correct. So the energy will be 1 upon 2a is less than infinite. So if a is positive, then right side decreasing function, and as this is a decreasing function, the energy will be finite and it will be 1 upon 2a. Okay. And the second case, if a is negative, then the energy will be, if a is negative, guys, if a is negative, then energy of x of t will be here 1 minus e to the power minus 2a to infinite divided by 2a. Now here a is negative, guys. A is negative. So if a is negative, like minus 2, suppose, if a equal to minus 2, then minus minus plus, guys, e to the power plus infinite, correct? It will be 1 minus e to the power plus infinite. This is a 2a, guys. Again a negative. So energy will be what? Plus infinite. This is negative. See, here this is minus infinite, guys. See, this is 1 minus infinite divided by 2a. Now numerator will be minus infinite. In denominator a is minus, correct, negative. So negative negative cancel out, minus minus cancel out. So in this case energy will be infinite guys. So here conclusion is what? Energy can be finite or it can be infinite guys, but energy cannot be negative. You can see energy can be finite or it can be infinite, but energy cannot be negative in any case guys, correct, in any case. And here you can see if A negative guys, A negative, then it will be the increasing function right sided, it will be right sided increasing function, yes or no? See, if A is positive, right sided decreasing function, if A is negative, right sided increasing function. So for the increasing function, energy will be always infinite, because you can see in the formula guys, see, if x of t is increasing function, infinite duration increasing function, from formula also you can see what you have to do, simply you have to do the square of the signal x of t, and then you have to find the area. Integration means area guys, correct. So you can see here, if x of t is increasing function, then of course the total area will be infinite, total area will be infinite or not. X of t is the increasing function, whether it is right side increasing or left side increasing, the integration will be always infinite. Even if it is constant like u of t, then also integration will be infinite. This integration value will be finite only when x of t is decreasing guys. You can see the simply logic. If it is decreasing function, then and then area will be finite, whether it is right side decreasing, left side decreasing, or both side decreasing, correct. So here the final conclusion is if the signal x of t is equal to e to the power, okay, then its energy is given by, energy of the signal will be, it is finite 1 upon 2a only when a positive, and it is not 0 but infinite. Energy cannot be 0 guys, energy can be between 0 and infinite guys. Will be not, it cannot be 0, correct, it cannot be negative, always positive guys. So this, see, the first question I am taking, first one I am writing, suppose I am asking to find energy e power minus 3t q of t. See, you can use the formula also. This is what? Decreasing function guys, right side decreasing function. It is what? Decreasing function, amplitude is 1 guys, amplitude is 1. So the energy, directly a formula also you can use, energy of this signal is given by, now see, this is the right sided signal, so integration will be 0 to infinite, directly steps elimination process. Right sided, that's why 0 to infinite. Now square of this guys, square of this, so e to the power minus 60 dt guys, correct, directly eliminated 2 to 3 steps guys. See, u of t, that's why 0 to infinite, and square of this signal e power minus 60. So here e to the power minus 60 divided by minus 6, here 0 to infinite. So answer will be 1 by 6. You can check, 0 minus e power minus infinite divided by minus 6 guys, divided by 6. So answer will be 1 by 6. You can write a unit joule guys, and unit of energy is joule. Okay. Second case, suppose x of t is equal to e to the power 2t into u of t. Now tell me, right side increasing or decreasing? I told you already, if same sign then increasing, if opposite sign minus t plus t decreasing, same sign then increasing function. Okay, so for this case, this is the right side increasing function. All of you are enjoying the content? Tell me guys, the premium content you people are getting in free guys. So all of you are enjoying this premium content or not? Tell me in comment box. Tell me your feedback. This is what? Right side increasing function. Now simply you can see guys, this is the increasing function. If you do the square of this signal, then also it will be increasing function. And if you integrate that signal from minus impact to plus impact, then of course the answer of the integration will be infinite, because this is the increasing function. And by formula also you can check. So again you can see right sided signal, so directly integration 0 to infinite guys. And tell me the presentation also clear or not? The presentation guys, because this is very much important. Are you finding the presentation neat and clean, or I need to improve presentation also guys? You can see the diagram and writing each and everything, because your feedback is very much important. If there is any improvement, then please let me know in this presentation also. So 0 to infinite, now square of this signal. Don't forget to square guys. So here e power 4t dt. So here e to the power 4t divided by 4 go to infinite. 0 to infinite guys. So here e power infinite is what? Infinite, correct? E to the power infinite minus e power 0 1 divided by 4. The answer will be infinite guys. So simply what you have to remember guys, if there is an increasing function right side or left side guys, if it is increasing function, then definitely the energy will be infinite for the infinite duration signal. And if it is decreasing function, then energy will be finite guys. Okay. So tell me, is this clear? Now one more observation guys, one more observation. Suppose e to the power minus 3 of t. What is the energy of this signal? Energy of this signal 1 by 6, correct? 1 by 6, this is the right side decreasing function. If you perform the time reversal in this signal, then tell me, is there any change in the energy? Time reversal operation. Time reversal operation. Time reversal operation. Now here, time reversal t become minus t guys. So what will be the energy of this signal? Will remain same. Time reversal operation. Can time reversal operation change the energy of the given signal? Okay. Tell me guys. So time reversal operation, just folding with respect to y-axis guys. Time reversal means what? Folding with respect to y-axis, correct? Time reversal means what? Folding with respect to y-axis. Folding with respect to y-axis will be like this. Okay. So let us calculate energy of this signal and tell me energy of this signal. Now see, this is the left-sided signal. Left-sided signal, so integration limit can we say minus infinite to 0. Left-sided signal, that's why minus infinite to 0 guys. Minus infinite to 0. Square of this e power 60 dt, yes or no? See, here this is the right-sided signal. So limit will be 0 to infinite. So right-sided signal 0 to infinite, square e power minus 60 dt. This is e power minus 60 divided by minus 6, 0 to infinite. So answer will be what? 1 by 6 joule you can see. Here you can see guys, e to the power 60 divided by 6, limit is from minus infinite to 0 guys. So if you put 0, 1, then e to the power minus infinite divided by 6. So again you can see the energy remains same. Okay. So time reversal operation doesn't alter energy of the given signal. Time reversal operation doesn't alter energy of the given signal. Is this clear? There is no change in the energy guys. There is no change in energy. Clear? So this is very much important conclusion guys. So here you can write in the short notes. You are preparing short notes regularly. Then in short notes you can write, if the energy of x of t, the energy of x of t is E guys, then the energy of x of minus t will be same, remain same. There is no change in the energy. So this thing you can write in your short notes. Write this in your short notes guys. Okay, time reversal operation doesn't alter energy of the given signal. Correct? Fine. So this is the first conclusion. So if it is left side decreasing, the energy will be 1 by 2 into 3 guys. If it is right side decreasing, then again energy will be 1 by 2 into 3. Remember this thing, energy cannot be negative. Energy cannot be negative, it can be positive or it can be infinite. Okay, so energy E should be greater than 0 guys, should be greater than 0. Okay, so either it is right side decreasing, left side decreasing, energy will be always 1 upon 2A, where you have to consider magnitude of A. So here, so time reversal operation doesn't alter energy of the given signal. So I am giving certain questions to solve guys. Okay, now first of all tell me, first find energy of the following signals. Total 4 questions, I am giving you only 4 minutes. I am giving you only 4 minutes to solve all the 4 questions. So tell me. Respectively. If it is increasing function, see, right side increasing or left side increasing, energy will be infinite. If it is decreasing function, then 1 upon 2A guys, and energy cannot be negative. Directly you can give the correct answer. So tell me answer respectively. Sinchan and Manoj, I'm expecting answer from you people also. I'm expecting answer from each and every single student. Tell me your answer in comment box. Infinite 1 by 6, 1 by 10 infinite. Okay, very good. Now see here plus t plus t. So this is right sided signal, but right side is increasing because plus t already I told you. So it is increasing function, and if it is increasing function, whether that is right side or left side, energy will be always infinite guys. In second case, this is left sided signal, minus t plus t. So left side decreasing function, opposite side means decreasing function, and you have minus t, that's why left side decreasing function. So the energy will be simply T is equal to 1 upon 2 into 3 guys. So it will be 1 by 6 joule. Unit is joule guys. Clear? Okay. Now third question guys. So this is what? Right sided signal, opposite sign. Minus t plus t guys. So minus t plus t, that means what? Minus t and plus t. So minus t plus t. So minus t and plus t, that means what? Decreasing function guys. Right side decreasing function. As this is decreasing function, energy will be finite and it will be 2 into 5, which is nothing but 1 upon 1 by 10 joule. All of you are college going student guys, Nikhil, Sinchan and Manoj. You people are college going student. Which semester? Are you studying in which semester? Sinchan, Nikhil, Misra and Manoj. Second semester, fourth semester or sixth semester, eighth semester. Now last question. This is the left sided signal, same sign, minus minus, minus minus, same sign. So left side increasing function, and as this is increasing function, and as this is the increasing function, people are pass out. 8th semester, okay, no issue. So here left sided signal, both are left, sorry, this is the left sided signal, but left side increasing function, so that's why energy will be infinite. This is clear to you people? This is clear to each and everyone? Done? Done guys? Fine. So this is a simple way to calculate the energy of any signal, okay, any signal. Now here next part is can you calculate the energy of U of t signal guys? Try this question. Calculate the energy of unit step function. energy of unit step function. You can share this lecture with college going student also, guys. It will be very much helpful in their semester exams also. So tell me the energy. Infinite. Infinite you are getting. So let us see the energy of this signal. So integration minus infinite to plus infinite to square of t dt. Now square of u of t is nothing but u of t. So integration 0 to infinite u of t is equal to 1 dt. Correct? So it will be t 0 to infinite. The answer is finite, guys. Correct? So energy of unit step function is infinite. Suppose I am asking to find the energy of u of minus t. Correct? U of minus t. Then what will be your answer, guys? What is the energy of u of minus t? The energy of u of minus t will be what? Tell me. Holding with respect to y-axis. Again, time reversal operation doesn't alter the energy of the given signal. So here also answer is infinite. Okay, infinite, guys. Fine. Now tell me what is the energy of this S and T plus T, later we will see. Okay, all the question we will continue in the next class, guys. Okay, next class we will continue. Fine. So all of you, thank you so much watching me live on Gateway English channel, and please don't forget to provide your valuable feedback in comment box after completion of this session, because your feedback is very much valuable for us. Okay, so thank you guys, thank you so much, and next part we will continue into subsequent module.